Hi, welcome back. In this video, we're going to do our second example for determining normality. The data consists of games played each year in the career of Baseball Hall of Famer Bill Mazeroski. Determine if the data are approximately normally distributed. I have 17 data values here for the 17 years that Bill Mazeroski played. And I'm going to check the normality. So I'm going to step through the histogram, Pearson coefficient, and outliers. So to start with my histogram, I put my data into list 2. I already had data in list 1, so I chose to go to list 2. So I'm now going to hit second stat plot and go check, make sure my stat plot is turned on, that I've chosen a histogram, which is my third option. And then I need to change this to list 2. The frequency should again be 1. Now I'm going to hit zoom, and I'm going to choose option 9 for zoom stat, and it's going to show me this histogram. So I'm going to do a quick little sketch of my histogram. So this histogram I have short, a little bit taller, a gap, same height, much taller, much shorter. This distribution is not symmetrical. It is unimodal, but I would kind of say it looks skew left. From the appearance of this, just based on the histogram, I would say that this does not appear to be from a normal distribution. So based on this, I would say that this data does not come from a population which is approximately normal. But that's not quite good enough. Let's keep going and see what happens with my other values here. So now I'm going to look at my Pearson coefficient. Remember, my Pearson coefficient is 3 times the mean minus the median divided by the standard deviation. So what I'm going to do right now is pull the mean, the median, my standard deviation, my first quartile, and my third quartile, because I know I'm going to need all of these values, and I can find them in my 1var stats. So I'm going to hit the stat button, and I'm going to go over to calc 1var stat. I want to do the statistics on list 2. Make sure that that list matches where your data is, or else you won't have the right values. So my mean is 127.2. My standard deviation, I want the S value, it's 39.9. My median is 143. My quartile 1 is 96.5. And my quartile 3 is 155.5. So calculating this Pearson coefficient, I'm plugging the values into my formula, and now I'm going to calculate it. So 3 times 127.2 minus 143 divided by 39.9. That gives me a Pearson coefficient of negative 1.19. This is not between negative 1 and 1. This is actually a negative number smaller than negative 1. So this is skew left. If this had been positive 1.19, we would say that this is skew right. But because this is negative, it is skew left. Okay, so based on my histogram, I've said that it's skew left. Based on my Pearson coefficient, I've said it's skew left, which means it is not normal. So far, we are again not normal. But let's check our last, which is outliers. Do we have any outliers? This is our kind of last hope. But really, because we have either just the histogram or the Pearson coefficient is enough to reject normality, this is just a formality. I want to go through all of the steps so you could see all of the different things that could lead you to reject normality. We have to have all three to say that the data appears to be from an approximately normal population, but we only need one of these to be a rejection to reject normality. So my upper limit and my lower limit. And let's calculate my IQR. My IQR is Q3 minus Q1, which gives me 59. So plugging in my values here, for an upper limit, I get 243.5, and for a lower limit, I get 8. So now I'm looking for any outliers, which would be values greater than 150 or greater than 243.9 or 243.5. And I have no values greater than that or values smaller than 8. I have no values less than that. There are no outliers. Just because there are no outliers does not mean that it is approximately normal. But if there were outliers, we would really need to consider this. Because of the histogram and the Pearson coefficient, we say that the data comes from a population that does not appear to be normal. So based on this, I would not be able to use this data with a normal model to calculate or approximate anything.